The experimental investigation of atoms at the beginning of the century yielded sensational and totally unexpected results. Far from being the hard, solid particles, SPs, yes, of time-honored theory, atoms turned out to consist of vast regions of space in which extremely small particles, the electrons, moved around the nucleus. A few years later, quantum theory made it clear that even the subatomic particles, the SAPs, the electrons and the protons and neutrons in the nucleus, were nothing like the solid objects of classical physics. These subatomic units of matter are very abstract entities which have a dual aspect, like yin and yang. They have a dual aspect. Now, depending on how we look at them, they appear sometimes as particles, sometimes as waves. And this dual nature is also exhibited by light, which can take the form of electromagnetic waves or particles. Hence, the origin of the term quantum theory. And these are now known as photons. Anyway, this dual nature of matter and of light is very strange. It seems impossible to accept that something can be at the same time a particle, an entity confined to a very small volume, and a wave, which is spread out over a large region of space. And yet this is exactly what physicists had to accept. You've got to accept it, guys and girls. The situation seemed hopelessly paradoxical. Oh, I love that paradox. Until it was realized that the terms particle and wave refer to classical physical concepts, yes, that Newtonian stuff, which are not fully adequate to describe atomic phenomena. No. An electron is neither a particle nor a wave, but it may show particle-like aspects in some situations and wave-like aspects in others. As in, what is A and what is not A is not A. Or what is A and what is not A is B. But then again, A and B can both be predicates of X. What is it? The law of contradiction and the excluded third. Anyway, where was I? Electron is neither particle nor a wave, but it may show particle-like aspects in some situations and wave-like aspects in others. While it acts like a particle, it is capable of developing its wave nature at the expense of its particle nature, and vice versa. While it acts like a particle, it is capable of developing its wave nature at the expense of its particle nature, and vice versa, thus undergoing continual transformations from particle to wave and from wave to particle. Physics. Oh, it's that book, The Turning Point. I thoroughly recommend it. The Turning Point by Fritjof Capra. Science, Society, and the Rising Culture. Yes? Fluid dynamics. Physics, amigos. Look at that. Can you see? Whizzing around. Can you hear that? That's water. That's what that is. Look. See? Fluid dynamics. Splish, splosh. See? Oops. It's spilt. It's a little something for the spirits. Fluid dynamics. Be like water. Look at that modern art. And this. Is physics. Oh, there's a horse. Calm, Dobbin. What's this? Oh, look, it's a Black Panther cat thing with a red block behind him. And what's that? Some yin and yang creature. Oh, he's got super cool shades. But anyway, let's get back to the physics, amigo. Check this out from another angle. Very interesting. I see. Look. Physics. Cause, effect. Cause, effect. Cause, effect. Cause, effect. Cause, effect.